Welcome back, chemistry fans. We are going to be participating in the classroom maybe today, maybe in the lab with the mole. So we've got to figure out, how does this stuff we just learned about actually relate to things that we can touch? So let's try and figure out how many atoms, how many molecules there are in some samples. So what I'm going to do is I'm going to turn my camera now over to the desktop here, and we're going to try and figure this out together. So at my desktop, I have a fabulous little scale here. Let me turn my camera around so now you can see it. And what you will notice is that it is at 0 there. So what we've got here is just a sample of aluminum. It is a cylinder called an ingot. And what we're going to do is we're just going to place that right on here and record what that value is, 17.61. 61 grams of aluminum. Great. My goal now is I want to be able to convert grams into moles and then convert moles into atoms. How many atoms are there? And if you didn't know that, this is not for you because that was yesterday when that was recorded. So how many atoms are in this bar of aluminum? We're going to figure that out. So we're going to follow the mole map. In the mole map, what we've got is to go from grams to moles. We divide by the mass off the periodic table, and then we will multiply by Avogadro's number to turn it into atoms. So here we go. I've got 17.61 divided by the weight off the periodic table, which is 26.98. Ooh, 26.9815. So I've got that on my calculator. 17.61 divided by 26.9815, and that is 0.65. With the sig figs, I got to have 4 sig figs. Well, I'll keep running it out because it doesn't matter. All right, now the second step, because we're not done yet until we get to atoms, is that I'm going to multiply by Avogadro's number. It's important that you demonstrate that you understand how to do that task. So what I'm going to do is I'm going to multiply this by 6.02, and I push the second blue button, and then I push right above the 7, I push a comma, and then I would have 23. And what that gives you then, times 10 to the 23rd, is 3.929 times 10 to the 23rd atoms. Not a difficult task. We're going to do the exact same thing now, this time though, with a molecule, not with an atom. So what we're going to do is we're going to take NaCl. And I'm going to place on it just a little container here to hold it into place. And let's see if I can get this thing to tear. See if I can get this where you can see it. So what you'll notice there is it's 0 now with that scale on there. And so I'm going to pour just a little bit of my salt in there. And it says that my salt amount that I poured in there is 2.63 grams, 2.61 grams of salt. So what our goal is to figure out how much salt, how many molecules, not atoms, because these are molecules. An atom is just one element. This is a molecule. So we want to convert it into moles, and then not into atoms, but into molecules. Now it goes through the same process as we just did. The only difference is the name. We start with grams, we convert it to moles, and then we go from moles to molecules. So I'm going to take my 2.61. I'm going to divide it by the weight of sodium and chlorine added together. Sodium is 22.98. and chlorine is 35.45. So I add those two together and I divide 2.61 by that number, 2.61 divided by the sum of 23.98 plus 35.45. And what I get is 0.0431721, blah, 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 blah. But that's moles. That's not what we're looking for. We're looking for molecules. So what I got to do again is multiply it by Avogadro's number, following the mole map out here. I multiply by Avogadro's number. I divided by the mass here. And so I end up that number times 6.02 to the 23rd, and I get my final answer, 2.644 times 10 to the 22nd. What are my units? Molecules. Okay. Let's do one more. One more example, and this time what we're going to do is sugar. Sugar is sucrose. So what I'm going to do is the exact same process I started with before. I'm going to take my mass of this material. I'm going to first get no weight for my container that's holding it. I'm just going to sprinkle a little bit of sugar in there. So my sugar, it says I got 0.95 grams. 0.95 grams. That's what I'm going to write down. 0.95 grams of sugar. Well, that's C12H22O11. Well, that's going to be a pain to add all that together. It's just shattered. That's what you do. You're on live camera here. And so what we're going to do is we're going to need to divide this by the weight of all those carbons and hydrogens and oxygens. So carbons, there are 12 of them, and they each weigh 12.01. There are 22 hydrogens, they each weigh 1.0079, and there are 11 oxygens, which weigh 15.9994. So we're going to put all that together. 12 times 12.01 plus parentheses 22 times 1.0079 plus 11 times 15.9994, and you get 342.2872. So I'm going to take my 0.95. I'm going to divide it by 342.2872. Boy, I wrote the wrong number here. I forgot one of my twos. Okay. So I'm taking 0.95 divided by 342, and what you get is 0.002775447. Now that's moles. That's again not my final answer. Because if you recall, what we want to do is we want to go from grams into moles and then moles into molecules. So to do that, we had to divide by the mass off the periodic table, and then we multiply by Avogadro's number. So here we go. We got to multiply by Avogadro's number. So I have this value here. I'm going to multiply it by 6.02 to the 23rd. And what you get is this number times 6.02 times 10 to the 23rd is our final answer, 1.67, and it's 2 digits, so it's actually going to be 1.7 times 10 to the 21 molecules. And that's our final answer. Okay, folks, this is what I want for you to do, but here's the deal. I've just done it. You are going to do it with your own numbers. So here's how you're going to figure out what numbers you are doing these with. You are going to do the birthday trick. So for your first one, aluminum, the mass that you're going to use is your month plus day. So in other words, I was born on January 1. I'm sorry, I was born in January on the 6th. So I'm going to use 7 grams. That's what I would use for my first one. And then the same is going to happen for the salt and for the sugar, C12H22O11. You are going to use the same amount for each of them, but your answers are going to be different because these materials weigh something different. But you're going to use your birth date, and that's how I know that you have been participating and not just copying down someone else's work. Thank you.
Or home monitor for PSATs and this training today, please report to the lecture hall at 2:30. Training will take 15 minutes.
All right, folks, I will talk with you again. Thank you so much for paying attention. Hopefully you continue to practice. I will talk with you again soon. Bye-bye.